Hello everybody and welcome to another one of our live trainings on Unity. My name is Mike Geig and today we will be talking about mobile development. If you are on our Facebook page, then you've seen a version of this picture before, but I decided to spruce it up with an American flag cape because, what can I say, I'm a patriot. So today we are going to be talking about mobile development, and we are going to be basically targeting kind of how we start, right? You're going to notice that a lot of programming for games for mobile is pretty much exactly the same for web or for desktop. So I don't really need to get into a lot of depth there because really not a lot of depth is needed. When you're thinking about mobile platforms, there's really only two things you need to keep in mind that's different from, say, desktop or anything else, and that is A, how are you going to control the game, because input is very limited on a mobile device, and B, what kind of screen real estate are you going to have, and what kind of hardware power are you going to have, because, you know, we all know that mobile devices can't run as intense of games as anything else. We've got a lot of people participating in chat today, so obviously I'll be moving along with the lesson and trying to keep up with the chat. So if you hear me pausing for a bit, it's because I'm reading chat and trying to answer your questions. I haven't said it in a while, but you know, if you have questions during the lessons, obviously post your questions in chat, and you know, I'll try to answer them. Okay, so yes, I hope you all enjoy my my super awesome picture there. Okay, so and someone had mentioned before something about data persistence. That was last week. This week is mobile development. I changed the title, but some people are still seeing it say data persistence. So today is mobile. Yeah, so there you go. Okay, so before we begin, like always, if you have any questions, comments, concerns, anything like that, you can follow us on Twitter at Unity3D, at Mike Geig, which is me, at Will Goldstone, and at the Ant Ranch. We love talking to you on Twitter, and yeah. So if you have any questions or you just want to talk, Twitter it up. For those of you who watched last week, I was in London on a Mac and trying to figure that whole thing out. Today I'm back in my house, and so I'm back on my computer, Windows, which I'm much more familiar with, and I have my mechanical keyboard. So I know some of you last week were really missing the mechanical keyboard. This week it's back. So if you don't like the mechanical keyboard, sorry, it's back. But yeah, someone asked in chat if I work for Unity. I do in fact work for Unity. I am a screencaster / trainer for Unity. So, hello. Okay, so let's start talking. So, the first thing we're going to do when doing any mobile development in Unity is we need to set up our mobile development environment. By default, Unity integrates with the SDKs for whatever mobile device we want, but we have to actually have those. So some of the steps, obviously, I'm not going to talk about right now, is that you need to download the SDK. So if you're using Android, you need to download the Android SDK, and the documentation on Android is on Android's website on how to do that. You download and install the Android SDK, and update it and do all that stuff. And if you're on iOS, you need to download Xcode and all the Apple goodness stuff. All right. So those two things have absolutely nothing to do with Unity, so I'm not really going to talk about them, but they have to be done. Let's see here. Question: can you use Android Nexus 7? Absolutely. Yeah, you can pretty much do a lot of Android and iOS and whatnot. And there are some limitations as to which stuff Unity will run on, but for the most part, we cover pretty much all devices, or most devices, and more every day. So, assuming we've already downloaded and installed Android or iOS, we need to basically tell Unity about it. Now, with iOS, Unity is automatically going to know about it. So you just download your Xcode, you know, you set that all up, and Unity will know where it is because it's always in the same spot. You will need an iOS developer's license. I'm not an iOS developer. I don't own a Mac, so but I believe it's a $100 license fee through them, though I'm not entirely certain. And you need to log into that service before you can do iOS dev. The Android SDK is free, though it's a little complicated to get set up. So obviously, consult the documentation because it's a little bit different. Now, Android, since you can install the Android SDK pretty much anywhere, will not automatically be recognized by Unity. So you need to tell Unity where it is. And to do that, you're just going to come into Edit and then Preferences, and click this External Tools option. And right here, you're going to see Android SDK location, and you just need to tell it where you saved that information. And from then on out, it will say, hey, okay, so we know where your SDK is, and all that is working fine. Ooh, man, chat's crazy. Will I be at GDC? I will, in fact, be at GDC. So if you're going to GDC, message me. We'll hang out. Let's see here. Some people are talking about my mechanical keyboard. Okay. Are you going to cover using different quality assets like images for a 2D game? We'll talk a little bit about resolutions and images near the end of this. Let's see here. Let's see here. I know, someone says let him get started. I'm getting just destroyed by questions right now. Maybe we'll do a second mobile session that's just QA, because you all seem to have a lot of questions. Let's see here. We're going to avoid platform specifics today. We're not going to talk about platform specifics. Can you use the free version of Unity, or do you need the iOS, Android, Windows add-ons? I believe there's a free version of the iOS, Android add-ons. There's like a free version, a $400 version, and then like the more expensive Pro version. I think, man, it's been forever since I looked at licensing. You'll have to go to Unity's site and check it out. I honestly cannot remember. Let's see. Yeah, so someone said to do Android 2.2 and greater, or 2.3 and greater, which is right. Let's see here. Okay, so yes, it's a lot of basic questions. What is an SDK is one of the questions that just popped up, and an SDK is a software development kit. It's basically a whole bunch of ways for us to interface with some hardware or something else, right? So an Android SDK allows us to write applications for Android. But anyway, okay, so at this point, we're going to pretend like we've installed Xcode or we've downloaded Android, and that's all good to go. So at that point, our editor is ready to go, but there's a couple more steps that you really want to do. The first thing you want to do is come into File and Build Settings and ensure that you are currently set up for whatever platform you're building for. So I'm building for Android. You're going to see, though, the things we do today, it won't matter if you're on Android or iOS. So if you're following along, or if you're watching this later in the archive and you want to follow along, it really doesn't matter if you're on Android or iOS. It's really irrelevant, because all the stuff we're going to do works for both. And I believe it all works for the Windows Phone 8 as well, but I've not personally tested that, but I'm pretty sure it's the same. So yeah. So anyway, if you're, say, currently on PC, Mac, or Linux standalone, you'll just want to select your platform and click this Switch Platform button. You can see that I'm already on the Android platform because I have this little Unity icon here, which means I'm currently building for Android. That's the platform it's currently on, and we don't really need to mess with any of these settings right now. I've also already added my main scene here, but we're not going to really worry about that right now. So we need to, obviously switch to the appropriate platform. Another thing I want to do, I generally always do, is I try to set up my my aspect ratio. So in this case, I'm in 16:10 landscape. You're going to see that you're going to have some different options, all right? Because I switched my platform to mobile, so I don't see the standard options that I normally see. I see a whole bunch of different options. In this case, I'm choosing 16:10 landscape because my test device happens to be a Nexus 10 tablet. If depending on what device you're using, you'll want to pick an appropriate aspect ratio for that. Okay, let's see here. Geez, all right, so a lot of questions in chat, craziness. Anyway, so I'm gonna kind of skip a lot of these questions because I just can't get to them right now. I'd really like to get started. All right, so our editor is in the appropriate build mode. In my case, it's Android. I've set up my game to have the appropriate aspect ratio. So now, the first thing I want to do is I want to talk about touch input. There's basically predominantly two ways to interface with a mobile device, and that is a multi-touch screen, which most devices nowadays have a multi-touch screen, and also the accelerometer, right? And iOS devices also have a gyroscope, which functions kind of similar to an accelerometer. We're going to ignore the gyroscope for today because we can do pretty much the same stuff with the accelerometer, and since Android devices generally don't have a gyroscope, it wouldn't be something that applies to both. So as I said, I'm trying to do things that apply to both, so I'm skipping the gyroscope. But the input device, if you're reading Unity's documentation, Unity's mobile documentation is a little bit older. It talks about how iOS only allows 5 touches, and Android allows somewhere between 2 and 5. And it has been my experience now that both iOS and Android allow well over 10 touches, or 5 touches. Obviously, how many touches depends entirely on the device, but that number is a little bit low. So what we can do is we can read in whatever is touching the screen. And generally our devices are touch capacitive screens, which means it has to be something like your hand touching it, something that will conduct current. And that's how the device screen knows where our hands, our fingers, or whatever, our stylus, pens, or whatever, are touching the screen. Now, since our screens are flat, we are dealing specifically in screen coordinates, right? So obviously we don't have an X, Y, and Z axis with our mobile devices as far as touching goes, because the screen is basically a flat canvas. And so I have this little amazing infographic here that basically talks about how the position works on mobile screens. All right, and so basically the lower left-hand corner is 0, 0. All right, is the origin, and basically it goes from 0 to the screen's height upwards, and 0 to the screen's width rightwards. And so that is our screen coordinates. Now this doesn't matter if we're in landscape mode or portrait mode. Basically, the lower left will always be 0, 0, and height will always be up, and width will always be over. So if you're in portrait mode, the system updates to the lower left-hand corner, and if you flip to landscape mode, again, the system updates. So yeah, basically, wherever we touch the screen, it's going to be a 2D coordinate, right? It's going to have an X and Y component, and it's going to be some X position, comma, some Y position. Yeah, someone said in chat, don't forget the Z-axis is towards the user. Not when we're talking about screen coordinates. There is no towards the user because this is flat. Yeah. Someone also mentioned that I thought 0, 0 started at the top left. In some instances, 0, 0 is the top left, but in this instance, 0, 0 is the bottom left. So that's just how this is handled. And so we can, so if we're talking about the GUI system, the top left is 0, 0, but we're talking about mobile touchscreen coordinates, and it's the lower left is our 0, 0. So okay, so let's talk about touches. So basically, touches are stored in an array, because we can have more than one touch, right? And so we can't just be like, hey, what's our one touch? We need a collection of touches, and we access all of those through the input class, just like we do any other form of input, because the multi-touch screen is also just input. So basically, what we need to do is we need to access the input class, and we need to find this information about our touches. We do that all through script. So what I'm going to do is I'm going to go ahead and just create a script. I'm going to create a C# script, which I'm just going to call touch script. Oh, one more thing I want to talk about today real quick. I am using the Unity Remote application on my Android device. So I'm doing that specifically so you guys can see what I'm doing. If you think about it, normally the best way to get good performance, good reliability, is to build my project, send it to my Android tablet, and test it on my Android tablet, right? However, you won't be able to see that. You're all watching my computer screen, and I don't have another camera to show you the contents of my tablet. So I've installed the Unity Remote on my tablet, and you can find the Unity Remote from the Android store and from the iOS store. It's just called Unity Remote. It's free. If you find that you're being charged for it, you're getting the wrong one. Unity Remote is free. And basically what that's going to allow me to do is it's going to allow me to use my tablet as an input device into the editor, so I can test my mobile application in the editor. Now, the reason, I mean, that works, but it can be a little buggy. Sometimes it doesn't work, and it forces or imposes specific orientations on me and stuff like that. So it's not as fluid as just basically deploying to my device and testing it that way. So just keep that in mind. What I'm doing is I'm using the Unity Remote. You're more than welcome to do that. Unity Remote is fantastic. It allows me to test in the editor. But when I want to do real testing, I deploy to my device. All right, so Just keep that in mind. And yes, someone has said in chat it is a bit laggy. The Unity remote is, so that's effectively what I'm using. So you're gonna basically see that. And so I'm gonna go ahead and just put this touch script on my main camera. You can see here I just have a scene. This just got a cube, a direction light, and a main camera. So in case you're wondering what I already have in here, nothing really. And I'm gonna go ahead and open this touch script. There we go. And I'll zoom in. The problem is always seeing stuff. Oh, chat's going crazy. Oh, let's see here. That's a lot of language I don't understand because that's not English. Let's see here. That's a lot of not English. I don't know what anyone's talking about. Everyone's talking in a different language. Okay, let's try to limit chat to being specifically about the topic right now. And preferably, at least for me, to be in English unless you don't speak English because... well, if you don't speak English, you're not going to be getting a whole lot out of this live session anyway. But it's a little distracting, so. All right. So the first thing we want to do is we want to kind of get the touch information. And like I said before, the touch is stored in an array. And that array is called touches. So I can access input.touches. And this is an array, and I could just be like touches sub 0, touches sub 1, whatever, right? So there's this array of touches, all right? A lot of times I would want to iterate through this array of touches, and that's actually what we're going to do here in a second. But before we do that, I want to talk about an individual touch. A touch is a class. And so what I want to say is something along the lines of touch, I don't know, my touch equals, and let's say I want to get the very first touch, right? I just want to put my finger down and get that one finger position directly on the screen. I would do inputs.getTouch, and this will give me back an index member from the array. I want 0 to give me the first touch. I've just been informed that the language people are speaking in chat is Turkish. So, okay, hello. I did not know that. Thanks, Christina. Appreciate it. Okay, and so what this is going to do is this is going to give me back the first touch in the array, which I will store here is my touch, from the touch struct. And touch, in fact, is a struct and not a class, which for our intents and purposes right now really doesn't matter. All right, so just keep that in mind. And so this touch has a lot of stuff that is very useful to us. All right, so let's consider. I'm just going to go my touch. I'm just going to hit dot, and let's look through the things that touch has. All right, so the first things first is touch has a delta position, and a delta position tells me how much my finger or whatever device is touching the screen has moved since the last time it was looked at, since the last update. All right. Delta time is the amount of time since the last update, which most of the time delta time is the same as time.time unless you're pulling for your input somewhere else, right? But usually delta time will be the same as time.time. Finger ID tells me which finger it is. So if I put my index finger down on the screen, my finger ID will be 0. And if while holding that on the screen, I touch it with another finger, that finger ID will be 1, and so on and so forth. So finger ID is the index of the specific touch. Then we have phase, which is what phase the touch is in, and the phases are begin, moving, stationary, and ended. So begin is the first frame of a touch, stationary is if the touch isn't moving, moved is the touch did move, ended means I picked my finger off the screen, and then there's a fifth one called canceled, and canceled is only if there's some error and it can't read the input. The position is its position on the screen. Raw position, I actually don't know what that is. Raw position. I don't know. Maybe we'll look at this here in a second. I always just use position. I have no idea what raw position is. So yeah. Maybe raw position is the screen position without menus and stuff like that. Because I know in Android it's got that little menu bar at the bottom, and so it doesn't count that as part of its position. So maybe raw position is without that. I'm not entirely certain. Tap count is how many times you're tapping your finger, and it keeps track of that in case we're doing quick taps. And then toString just kind of outputs the class because that's something that's inherited. So those are all the pieces of a touch, all right? And I can just get one touch, which we're actually going to look at doing here in a little bit, and I can do stuff with that, all right? But for now, I don't want to mess around with individual touches. What I want to do is I want to output to the screen information about a bunch of touches. So 1 second here, I am just reading through chat. Let's see here. Okay, nothing that is really pertinent. Again, please try to keep chat relevant to what we're doing here. So here's a question: how does finger ID work if you put down one finger and then put down another? Remove the first finger while holding the second one. So basically, if I put down one finger, it's going to have an ID of 0. If I put down a second finger, it's going to have an ID of 1. If I pick up my first finger, my second finger will still have an ID of 1, and 0 will be freed up. So it's not like it switches or anything like that. It keeps track of the fingers while the fingers are touching, right? And actually, here in just a second, we're going to build basically a little demo here that's going to show you exactly how it works. And so that's what we're actually, let's do that right now. And so I don't really care about update right here. So what I'm going to do is I'm going to do an onGUI method. There's that mechanical keyboard for you guys. And so what I want to do is I want to iterate through my collection of touches, and I want to output some information to the screen about those touches. All right. So I'm just going to do a quick for each loop, and I'm going to say for each touch, in input.touches. Oops. I don't know why I did acceleration. Input.touches. So this will go through all of the touches in this touch array, and I'm just going to build a message here. So I'm going to do string message, and I'm going to say message plus equals. So what we're basically going to do is concatenate some information. So ID plus touch dot finger ID plus, this part gets a little long-winded. And let me see here. Let me just copy this, because we're basically going to be doing this a bunch. So that's our ID, and then we're going to say, hey, what phase is it on? And we'll do touch dot phase, and the phase needs to be .toString. And then we'll say touch dot after phase. Let's go ahead and do tap count, which again will be touch dot tap count. And then we'll do after tap count. Let's do say position. Let's do position X. Position X, and that will be touch dot position dot X. And let's do let's do position Y, which it will be position.y. All right, and then let's do, we're going to need to do a little bit of an offset so these don't all overlap each other. So I'm going to do int num equals touch.fingerID, and then I'm going to say GUI.label, and that label will be positioned at new rectangle, and that new rectangle is going to be 0 plus 130 times num. This will allow us just to offset them across the screen. You'll see in a second what this is doing. 0, 120, and 100. And then message, which is the message string we just created. All right, so what this is going to do is it's going to go through each touch I have on the screen, and it's going to output this information to a GUI label. This part here, the num, just allows me to offset it. So the first finger will be at 0, the second will be at 130, the third will be at 260, and so on and so forth. So we can have them all kind of cross the screen there. All right. So let's go ahead and save that, and let's go back into Unity. And let me wake my tablet up here. And hopefully the Unity remote picks it up the very first time. So I'm opening up my Unity remote, and I'm going to hit play. The Unity remote did pick it up. So now I'm going to touch the screen with one finger, and I see ID 0, phase is stationary, tap count is 1, position X and position Y. And as I move this, you'll see it flips between stationary and moved. It's updating obviously much faster than my finger is moving, so we supposedly see stationary, but we can see exactly where I'm touching. All right, if I pick it up, it goes away, put it down, it comes back. If I put a second finger down, there was our second finger, third, fourth, fifth, sixth, seventh. Wait a minute, let's try this again. Oops. I lost my my tablet. There we go. Okay, so let's try this. 1, 2, 3, 4. 1, 2, 3, 4. Oh, it fell out of its case. See what I was saying about the remote kind of being a little weird? Anyway, you get the idea. If I would actually deploy this to my device, it would be much more accurate. But since I'm running it from the Unity remote, it can get a little bit iffy. Well, now I kind of lost track because it just goes off the screen. But anyway, so I got 8 at least. So there we go. But basically, using this, I can just see all sorts of information about a bunch of different touches. And basically, oh, it looks like 9 is the most my device will allow me. Because down here in my console, I see out of free touches. So that must mean that that after I did 8, that was it. So 8 must be the maximum on this particular device. Because then I started getting the error out of free touches. So yeah. So basically, you know, this is just a real simple ways that we can see kind of how the different parts change. Now watch, I'm going to tap my finger, and it kind of flashes there. But let's see if but it does say tap count 2. Real quick, because it means I tapped my finger twice. Oh, there we go. I got up to tap count 4. So basically, if I'm to hit real fast, oh, I got up to tap count 8. So you can see that we can allow Unity to recognize different tap counts. Now, another thing about the Unity documentation, if you go read the Unity mobile documentation, it's going to say that Android does not support tap count and iOS does. It didn't a long time ago, but now obviously I'm using an Android device and it supports tap count just fine. So tap count does work. So if you're reading that on there, don't think, you know, that it doesn't do that anymore. Okay, so now I see that people are talking about C# versus JavaScript. Okay, apparently no one wants to listen to me and just keep the talk about mobile development. But let me see if there's anything that I should be answering in here. Let's see here. People are just... How many fingers do I have? I have 10 fingers, which is... It's unfortunate that I didn't have 10 touches that I could utilize. I put the script just on my camera. It doesn't really matter where you put it. It's an on-GUI function, so it'll run from anywhere. Let's see here. Yeah, it's on the camera. Yeah. Yes, this will be archived. All my videos are archived for anyone wondering. Let's see here. All right, so... Okay, for those of you who said that it says stationary all the time, it actually flips between stationary and move, but just really, really quickly, because remember, this is running, well, how many frames a second? This is running like 300 frames a second, and you don't really know how fast the update method is actually being called, but it runs fast, so obviously, to do something moving that fast, my finger doesn't seem like it's moving at all, so just keep that in mind. Okay, so that's a real simple, just like, hey, let's output stuff to the screen. Oh, and here's another question. Is touch class already... Well, touch is not a class, but the question, is touch class already in general library, or do you need a special input? It is already... it's part of Unity Engine, so you do not need to call an input or anything like that. Yeah. So, okay. So, now let's do something a little bit more interesting. I'm going to go ahead and turn that touch script off, and let's move this cube with our finger. So what I'm going to do is I'm going to create a C# script, which I'll just call move script. And let's go ahead and just click and drag that onto the cube. There we go, and let's open it up. Alright, so basically what we want to do is we want to say, hey, if there is a touch, we want to move this cube. So let's just come down in here, and I'm going to say if input touch count equals 1, means there's exactly 1 touch on the screen. So what this means is if I put 2 fingers on the screen, I won't be able to move the cube. And if I'm not touching the screen, I again won't be able to move the cube. I have to have exactly 1 finger on the screen, or a stylus, or whatever, which is 1 touch read. All right. So if my touch count equals 1, then what I'm going to do is I'm going to say transform dot translate, and what I'm going to do is I'm going to say input dot touches. This time I'm just going to use the array. The next time you're going to see me get a reference to it using get touch. So dot delta position. So basically, how much has the finger changed over the course of the frame? Dot x. And in this case, we're going to dampen it a little bit by multiplying it by 0.25. That's just going to make it not go super duper fast. And then in the y direction, I'm going to do the same. I don't know why that just said space right there. In the y direction, I'm going to do input. And actually, I'm just going to copy this. Yoink. I'm going to do input.touches delta position y, and then I'm not going to move in the z direction. 0 in the z direction. Okay, obviously I'm stacking this up because otherwise it wouldn't fit on the screen because I'm zoomed in so far. So basically what we're saying is if we have 1 touch, then what I'm going to do is I'm going to translate this cube by the delta position of x, by how much x is moving. All right, and that's going to allow us to touch the screen with our finger and move things around. So let us come back here to Unity, and I'm going to hit play. And I'm just going to touch my screen, and you can see that I'm able to move the cube around just by touching my, my tablet. So the cube moves around. Now, you are going to notice that the cube does not move exactly with the finger, right? So my finger's moving a little bit, the cube is moving more, just because I'm using a perspective camera, it's not a 1-to-1 ratio, so, you know, the cube is not, I mean, I'm moving the cube, obviously, but it's not quite the same, all right? So, what I'm going to, but I mean, it works, right? That's specifically what I wanted to show you, how to do. But let's do this. Let's say I want the cube to move exactly where my finger is touching, right? Like by using some percentage of the screen width or height. Now, that is certainly doable, but it's not really doable the way we have it now. So what I'm going to do is this, I'm going to, this part is just for aesthetics, but I'm going to change my camera to be orthographic. Okay? Again, that I don't need to do that. That's for aesthetics, so that it looks more pleasing. So I'm going to set this to orthographic, and then I'm going to modify MoveScript. So I'm going to come back into my MoveScript here, and in this case, we are going to make some changes. So I'm going to go ahead and get rid of this line of code, and I'm going to instead say touch equals input.getTouch. I just told you I'd show you the other way, so I'm not just referencing it all the time. And so what I'm going to do is I'm going to create a float X and Y, and I'm going to set that up to a percentage of the screen width and height based on the position of my touch. Now, I'm just going to do the math here real quick. Just know that I determined this ahead of time. I determined that the left bound of my screen was negative 7.5, the right bound was positive 7.5, the upper bound was 4.5, and the lower bound was negative 4.5. So I've already calculated this out, okay? So if you're wondering where I'm getting these numbers, I already just moved the cube around and figured out where the bounds of my screen were. So I'm going to say float X equals negative 7.5 plus 15 times touch.position.x divided by screen.width. Okay, so basically, touch.position.x divided by screen.width will give me some percentage of the way across the screen my finger is. Then I multiply that by 15, and then I add it to negative 7.5. So that if my touch is all the way to the left, it'll be 0. 0 times 15 is 0, and it'll be at negative 7.5, which is my left bound. If my finger is all the way to the right, this will be 1. 1 times 15 is 15, plus negative 7.5 will leave me with 7.5, which is the right side of my screen. So that's effectively what we're doing here. And the same was going to go for Y. So I'm just going to go ahead and copy-paste, and I'm going to replace X with Y. I'll change this to negative 4.5. I'll change this to 9, and I'll change this to touch position.Y and screen.height. Okay, there we go. Okay, and so that is going to tell me the X and Y position in the game that correlates to the finger position on the screen. All right, and so then all I really need to do is I need to set my transform to that. So I'm going to say transform.position equals new vector 3, and I'll position it at X, Y, and 0. Again, we're not using the Z axis. Oh, chat's going crazy today. All right. Let's see here. Oh, by the way, yeah, so someone mentioned this, or I see some people talking about it. I'm using the GUI system just to show you guys some stuff. Don't use the GUI system with mobile devices. Hopefully we'll have a chance here sometime to talk about efficiencies a little bit. And the GUI system, as it stands right now, our current GUI system, is just not efficient enough for mobile devices. So don't use OnGUI with mobile devices. I only did it to kind of demonstrate that for you guys. So you won't want to do that. All right, and so this is all saved. So let's come back to Unity, and let's see what happens. So I'm going to go, I'm going to have an error. What did I forget to do? Something about a float casting. Oh, right. Forgot my Fs. That was a test. You all failed. You were supposed to point it out. Some of you might have. I haven't been looking at chat. All right, and so let's see here. I'll go ahead and hit play. And so now you'll see that I'll touch the screen with my finger, and I will move this around. All right. Yeah, and as someone pointed out, this works for all screen resolutions, right? Specifically because I'm doing position.x divided by screen.width. So it really doesn't matter what the resolution is. It'll work for anything. So yeah. Interestingly enough, the way I've set this up means I can just tap anywhere, and the cube will go to where my finger is touching. all right? Because now it just correlates to where my finger is. So I say I want to touch the upper right-hand corner. Just tap the upper right-hand corner, and there's my cube. Lower right-hand corner, or that was lower left-hand corner, lower right-hand corner, upper left-hand corner, so on and so forth, direct middle, whatever. And so this allows the cube to move with my finger. So once a person said here, wait, let's see here. You said that the left bottom corner was 0, 0, increasing x to the right, increasing y to the top. How can there be negative numbers if there's no space to the left and bottom from 0, 0? Because the negative numbers are in my game, right? Look at my game. So if I pick my cube is at 0, 0 right now. Let me go into 2D. If I want to move my cube to the upper left-hand corner, you'll see it's at roughly negative 0.5, 4.5, right? To the right. So I'm not talking about screen coordinates. I'm converting screen coordinates to world coordinates. That's what that is. Anyway. Okay, so that's what's going on there. Okay, so you can see that we can basically use input for all sorts of stuff, all right? So, and actually right now, someone mentioned that I'm using delta input. I'm not using, or delta position. I'm not using delta position. I'm just using position, right? I don't want the change in position. I want the actual position. So anyway, so at this point, you can see that we can use these touches for all sorts of stuff. I can move stuff around the screen. I can select items. I can shoot lasers. I can, you know, whatever I want to do. So yeah, the touch input is really cool. So now let's take a second. Let's talk about the accelerometer. All right, the accelerometer is our second form of input, and the accelerometer will basically tell me which direction the tablet is kind of leaning. All right, and it's actually really simple. Basically, I have a graphic for it. Basically, we have 3 coordinates with the accelerometer because the accelerometer tells us the device's physical orientation in real life, okay? And just like in Unity, the 3 axes line up in such that Y is up and down, X is left and right, and Z is in and out. However, in this case, positive Z is towards us and negative Z is away from us. But in Unity, positive Z is away from us and negative Z is towards us. So a lot of times you're going to see us use negative Z to get Unity to map to our device. All right, and what we can see is X is up and down, Z is in and out, or I'm sorry, Y is up and down, Z is in and out, X is left and right, and that works regardless of what orientation we're in. Okay, so if I flip my device from portrait to landscape, Unity will automatically update that stuff. Okay, so we don't really need to worry about the orientation of our devices. Now, that being said, let me show you how to choose that stuff. So again, I'm going to be using the Unity remote, and the Unity remote handles axes a little bit differently. It forces an orientation on me. All right, I don't really get to choose because it's just for testing, right? And so, but assuming I'm deploying my device, I can choose what orientations I want my device to be in. So I can come to Edit, Project Settings, Player, and I can look over here and see my Android settings, which my Android and my iOS settings are actually fairly similar. But I can see that by default, my device will be in landscape left. Now this obviously only is for when I actually deploy it, not for when I am using my accelerometer. I can also say, hey, I want it to be portrait. I can make it portrait upside down, landscape right. I get to choose what orientation my device is in. Now, if you want the user to be able to use the game, play the game in any orientation, or specific orientations, like say I want to enable portrait mode and landscape left. I want them to be able to rotate their phone and play it in different orientations. I can choose auto rotation. And once I do that, I can actually say, okay, I want to allow portrait. I don't want portrait upside down. I don't want portrait right, but I do want landscape left. Or I'm sorry, landscape right, but I do want landscape left. So I have some choices here where I can also hide the status bar, and I can do all sorts of stuff. But basically, you know, this comes into play with our accelerometer. However, again, just to emphasize that I'm using the Unity remote, so don't really get a choice, right? Because the Unity remote is just going to enforce. I can change the Unity remote orientation by changing my game orientation in the game view, my aspect ratio, but otherwise it just kind of fixes in because it's just for simple testing. Let's see here. Man, everyone's still talking about the GUI. Come on, guys. Getting distracting here. Trying to trying to see all of the different questions and not questions related to GUI. Let's see here. So when I have multiple, I'm sorry, chat's just going too fast. I can't quite read it quickly enough. When I have multiple elements I want to drag, how would detect touch on each of them? Raycasting. Yeah, so the question is, you know, if you're touching the screen, how do you tell what you're touching on? And you can just raycast. It's the same as clicking on it, right? You click and then you shoot a raycast from the camera to your mouse position. In this case, we can touch and shoot a raycast from the screen or from the camera to our finger position. So that all certainly works. All right. So anyway, okay, so more chat about regular stuff, but let's talk. Come back to talking about accelerometer now. So I showed you, or just talked real quick about how, you know, we can change our orientations and things like that. So let's look at actually creating an accelerometer script. And so I'm going to create a new C# script, which I'll just call Excel script. And basically, it's real simple. So our accelerometer will go between -1 and 1 in all three axes. It's just like input dot get axes, vertical, horizontal, right? We're just doing input dot acceleration, right? So it's just a vector 3 that has this acceleration information. It's actually really, really simple to use. One of the things you're going to notice, so I'm just going to tell you right now, is that you can really only utilize 2 of the axes at any given time, right? So you have 3 axes for your accelerometer, but if you think about it, I can, like, say I have my device straight up and down in portrait mode. Well, I can really only utilize the X and the Z axis. And you might be thinking, well, why can't I access the Y axis? Because gravity is pulling the Y axis down, like constantly. And so it's just going to be a solid -1, right? So it's really hard to utilize all 3 axes of the accelerometer at any given time, because one of those is always going to be pulled by gravity, right? So what we want is we want a situation where gravity is partially pulling on the accelerometers so that we can utilize them, but one is always going to be heavily pulled. It's really, you know, hard to orient a device so that doesn't happen. But okay, so let's talk about actually working with accelerometer here. So I'm going to go ahead and just remove this default CRUD, and what I want to do, and it's actually really simple, is I'm just going to transform this cube, or translate this cube based on my accelerometer. So I'm just going to say transform.translate. Oops, not transform.transform. That doesn't make any sense. Transform.translate, and how I'm going to translate is I'm going to say, I want my cube to move left and right as I tilt my device along the x-axis. So basically, if I turn it like a steering wheel, all right, that's me moving it on the x-axis. Right? Because if I'm rotating it about the Z, I'm moving it about the X. I know that's kind of confusing, but just imagine in your head like a steering wheel. And if I make a left-hand turn with my steering wheel, I'm going to the negative X-axis. If I make a right-hand turn, I'm going to the positive X-axis. And so what I'm going to say is I'm going to say input dot acceleration dot X. Okay? And then I'm going to say times time dot delta time. All right, so that doesn't, again, move really, really fast, right? So that will move me along the x-axis. I'm also going to move 0 along the y-axis, and then I'm going to just pop down a line here. And for my z-axis, I can say input dot acceleration dot z times time dot delta time. Oops, time dot delta time. And this works, but if you remember what I said before, with the device, positive x is towards me. But by default in Unity, positive x is away from me. So to make this work the way I want, I have to make that say negative input dot acceleration dot z. There we go. Gotta have that dot in there, or else it will not work. Okay, and so at this point, I can just hold my device up, and when I run this, you'll see that the cube will move. And actually, before I do that, I need to put the script on the cube. There we go. I also need to disable the touch move script. I don't have to disable that, but if I accidentally touch the screen while I'm using it, that won't do me any favors. So, okay. So now I'm just going to pick up my device here, and I'm going to kind of balance it. Let's go ahead and run this. And what we see, I'm still in orthographic camera. Okay, wait a minute. Let me come out of orthographic camera. Back to perspective. There we go. So let's see here. So now I'm going to run it, and I'm going to tilt it, and it's going to move this way. And I'm going to tilt it, and it's going to move this way, and I'm going to bring it towards me, and it's going to move towards me, and I'll push it away from me, and it'll come away from me, and there we go. So you can see I'm turning it like a steering wheel in my car. just like this, and now I'm tipping it back, and I'm bringing it forward. All right, so I'm utilizing the accelerometer. This is with it straight flat back, so this is maximum speed. And remember, it's a bit slower because I'm multiplying it by time.delta time. I could also create like a speed coefficient to make it faster. But this is basically me using the accelerometer in the device. You should see me. I'm in my basement swinging this thing around like a madman. But basically, I'm using the accelerometer in the device to move this cube all over the place. Okay? There we go. So, and we can use that accelerometer information to do all sorts of stuff too. Remember that it's just input.acceleration is a vector 3 that contains values between -1 and 1, right? So you can do with that anything you want, right? There's no real limit. So moving the cube left and right, that's only one possibility, and that's only one orientation. We can do all sorts of stuff with that information to create all sorts of wacky games. At its root, it is just a vector 3 that contains values of -1 to 1, and whatever you can do with that, whatever your imagination can do with that, you can do with that, right? So just keep that in mind, right? There's really no limit on any of this. I'm showing you this way to do it, but that does not necessarily mean this is the only way you can utilize it. You know, there's obviously a bunch of ways you can do that. One of the questions is, how fast is the response speed of the accelerometer? It's fast, but it's not perfect. So what you're going to see is if you don't multiply by time.delta time, it gets a bit twitchy, which means it jumps a lot. So a lot of times you need to do a little bit of smoothing. And by that I mean, instead of just directly translating it by the acceleration axes, say that, hey, have they moved more than, you know, or is it greater than, say, 0.001 or something like that. Otherwise it gets a little jittery. So you need to apply some smoothing to it, but this is how we deal with the raw input, right? Anything else that you kind of have to work on for yourself. Okay, so let me again attempt to read through chat here to see if there's any questions. Buttons, please. I'm not entirely certain what you mean, buttons. By default, or by the way, if you're using the on-GUI method, like I said, you really shouldn't with mobile, but if you are, you can just touch the screen and it will hit the button, right? So that just happens automatically. So if I were to say, I don't know, let's come back to our touch script here. If I were to say, if GUI.button new rect 0, 0, 100, 100, touch, I don't know, whatever. Camera dot background color equals, am I not allowed to modify that? Wait, color dot red. I don't know if that'll work. I'm not sure we can do this. I don't know, just off the top of my head. But again, you're really not supposed to use the GUI, but let's pretend. So with camera, I'm going to turn touch script back on. I'm actually going to, for my cube, I'm going to turn off my acceleration script, and I'm going to hit play. And then I get a touch button in the upper right hand corner, right? So if I just, oh, you know, it's not going to let me read it because I have this other thing functioning as well. But basically, you should just be able to touch, just like you can click it, you should be able to touch it with your finger. But so yeah, buttons are fairly simple, though you shouldn't really use the built-in GUI system. I generally, if I'm making something, I just make my own. Yeah. Let's see here. Unity Remote is on the App Store, so it doesn't come with any version of Unity. You just go to, like, say, the Android App Store or the iOS App Store and just download it. Question, can the accelerometer detect acceleration higher than 1G? I don't believe so, but you can multiply. Like, or I assume you're suggesting if you, like, hurl it. I don't believe so, but I've never tried, so it's really, I'm not really certain. Let's see here. Swipe movement, please. What do you mean by swipe movement? I'm not sure what you mean, because I showed you how you can swipe your finger on the screen and move a cube. Is that what you wanted, or well, I assume it's not what you wanted because you keep asking about it. Let's see here. Swipe gestures, like what kind of gestures? It would be nice if I could do a video on mobile performance in different screen sizes. So yeah, I mean, basically, the reason we have this aspect ratio is so we don't necessarily need to worry about screen sizes. Now, if you're talking about different textures to get the textures right, you can always utilize bitmaps, though they're not necessarily fantastic. I do know for a fact that you can always tell what the resolution of your game is by saying screen.width and screen.height, which will tell you what the resolution of your game is, and then you can set your background textures or whatever to the appropriate images. So it's really not anything that warrants an entire video because it's actually really, you know, quite simple to do, and so, you know, maybe we can put together a little demo or whatever about it, but yeah, it's actually pretty straightforward. I will say this. We have some videos on mobile coming out soon, and in there are assignments where we talk about some of the different gestures. So we have like a pinch zoom gesture and swipe rotation of a sphere gesture and things like that. And I think that's what a lot of you guys are asking for. And so actually, if you wait just a little bit, we'll have videos, you know, well produced videos, not just this live stuff, specifically on how to make those. So that might be rather useful. I don't. So again, you say player movement, and I'm not entirely certain what you mean. Gestures can mean anything, right? So so some you were saying player movement, some you're saying swipe equals gesture, and that's not particularly helpful. I'm not entirely certain what I can answer for you there. Can you swipe an object and it maintains momentum? Absolutely. So instead of like transform.translate when you swipe your finger, just do an add force and just that'll toss it all over the place. So yeah, you can do that. You can use force to move your objects based on the magnitude of the difference of your movement, of your finger movement, and just apply a force equal to that, and you'll get fairly accurate rotation that way. Let's see here. Let's see here. Okay. Please don't spam with the same questions too. Don't spam. I don't appreciate that because I'm trying to read, and if you're just taking up the screen with a bunch of the same stuff that doesn't really apply, I'm gonna have to ban you, and I don't want to do that. Let's see here. I want to be able to place different nodes via touch, click, make a path for an object to move. So you saw how I touch, right? I touch the screen, it returns an X, Y position. That's the same as clicking. So if you develop an algorithm where you click and it instantiates an object at that spot, right? The same applies, just a touch instead of a click. Both are just X, Y positions. One is the mouse dot position, the other one's touch dot position, right? But the mathematical algorithm works entirely 100% the same, all right? So yeah, so just keep that in mind, right? It's not anything magical. It's just think of your finger like a mouse, only with mobile devices you can have more than one mouse. So anything you can do with your mouse, you can do with your finger. Let's see here. Can you calculate force from swipe movement, like acceleration from delta movement? Yes, you can get the magnitude of the delta movement, and then just basically to add as much force as you want based off that until you get something that feels about right. Let's see here. So let's see. What about acceleration for 2D games? You use the z-axis too, or just up and down? Yeah. So if I was doing the acceleration for 2D games, I would just map like the z-axis to maybe the y-axis. Right. Remember, again, it's just a vector 3 of -1s to 1s, and so yeah, you can do whatever you want. Question, is Scaleform okay? I don't know. So I've used Scaleform before with UDK, but I've never used it with Unity. I can't speak to its performance. I've never tried it. Maybe you try it out. I don't really know. But like I said, if I'm doing a GUI, I generally just do my own. Like I'll create a sprite and just sort of slap that out there. Maybe text mesh or something along those lines. But yeah, I mean, you kind of just gotta figure out a solution that works for you. Let's see here. Why do I get different font sizes displayed on the Unity remote when I actually build my game? Because the Unity remote just kind of shorthands everything. So the Unity remote is not a completely accurate depiction of what the game is actually going to be like. It's just for simple debugging. If you want to be sure of what your game is like, you have to build it to a device. Let's see here. Is instantiate something we shouldn't use on mobile? So with mobile, efficiencies are super important. However, you're going to find that you're not necessarily always CPU bound as you are GPU bound. Fill rates and overdraws and shaders and stuff like that really are really where you lose a lot of stuff. So in here, let me load up a scene and show you. So I'm going to go ahead. I also have the sample assets here, and so I'm just going to go ahead and grab the particle scene, and I don't need to save any of that. And so the particle scene is basically this scene here. It's in the sample assets, so if you don't have the sample assets, you can just download them. The reason I have this scene loaded up is because I want to talk to you a little bit about efficiencies and draw calls, right? So anyway, kind of to come back to the question, should you not use instantiate? If you can object pool, you should object pool, right? Anytime you can do object pooling, that's the best way to go about it. But that's not always a possibility, right? And so sometimes you need to you know, instantiate, and that won't be a problem. But if you're doing it a lot, then it will be a problem, right? Because you will eventually become memory and CPU bound, right? But here, I'm going to go ahead and just hit play on this, and it's just going to rotate around. But the reason I'm doing this is because, first off, it recognized that I'm in a mobile platform, so it loaded up the mobile version of this. But I'm going to click this stats button here. And this stats button is going to become like your best friend. This in the profiler will become your best friend when building for mobile games, all right? And so we're going to see a few things, but what I'm really interested in is in my draw calls right here. Draw calls, and I can see that I have, depending, I'm bouncing between like 28 and 31, and I can also see how much I'm saving by batching. So the general rule of thumb is to sort of pick your target desktop environment. Maybe I want like an old desktop computer or something like that. So I pick that kind of in my head, or maybe I have that platform or whatever, and I build for it, and maybe it can run, and it has like 600 draw calls. It has 600 draw calls, and it runs pretty good. Okay, if I want to port to a similar mobile device, just drop a 0. So 60 draw calls or 600 draw calls becomes 60. So I know I can use the equivalent mobile device if I don't go over 60 draw calls, right? So stuff like that, right? That's sort of like a rule of thumb for drawing, or for mobile device. So I want to keep my draw calls low. In this case, I'm at 25, which is reasonable, right? That gives me a long way to get to 60. And I can also see that my tries and my verts are down. They're at 12K, or 12,000, which again is pretty good. And I'm also only using up a little bit of texture memory, which is fine. You can see there's really nothing here that's textured all that well. And so on and so forth, right? So basically, you know, this particular one runs very well on a mobile platform. It's, you know, it's because I'm in a mobile mode, and that sort of makes things a little bit easier. One moment here. All right, sorry, had to do something in chat there for a second. Let's see here. Yeah, sorry about chat. Please try not to spam. I certainly appreciate it. Let's see here. Do you need an Apple Dev account to test on a device? Yes, that is true. Okay, so I'm back here in Unity. Someone mentioned, how do you actually build for a device? So if I come to build settings right now, and I can see that my scene is in here. If I just hit build and run, Unity will automatically deploy that out to my device. So it'll create an APK file, but it will also push it to my device so I can actually run it, which is actually really nice, so I can see it run. This will only work if my device is currently plugged in, right, and my computer recognizes it, but basically you can see all that stuff. Let's see here. I just entered, where can I download the files for the training? There are no files for the training, so you've got them already. Congratulations. When this is archived, you'll be able to watch it again and see, yeah. Let's see here. Sorry, I'm just trying to read through. How about 2D movement? How about it? I don't know what you mean by how about 2D movement. Okay, let's see here. Why do some objects disappear on some devices when you move the camera, not out of view? Frustrum. It could be culling. It could be clipping planes. I'm not really sure. It just depends. It depends on your thing. Mike, can you make a quick list about what we really should avoid on mobile? Oh, that's a good question. Okay, so basically, avoid high amounts of draw calls, right? Those aren't doing you any good. Avoid a lot of physics intense processing, right? Avoid a lot of instantiate and destroy, because that's going to make the garbage collection run. Basically, you're making this to run like a really, really efficient PC game, right? Avoid shaders which are not made for mobile devices. Avoid those like the plague. They will kill your frames per second. So if there's a shader and it's not the mobile version of that shader, like, do not use it, okay? Always try to use the mobile versions of shaders, because that's what kills you, right? The main things that kill you are fill rate, you got a big screen, right? Overdraw, and shaders, right? So, you know, avoid shaders that aren't built for mobile. Always, so besides what to avoid, also try to atlas as many of your textures as possible. Try to have as many objects use the same material as possible, right? For each individual texture, that's one draw call. But if you have all of these different textures in the same texture atlas, thus one file, right? That's one draw call to draw all of them, right? Only when they share a material, obviously. Unity Pro allows you to set things up as static, which means they can be statically batched. By default, we're automatically dynamically batching, right? That's where the system is like, hey, these two things are the same, let's batch them together. Static batching allows me to specifically state that these should be drawn together, and thus turning multiple draw calls into a single draw call, making things more efficient. That is Unity Pro, but that's something that's good. So static batching. Occlusion calling, again, in Unity Pro, but super important. There's no sense in drawing things that don't need drawn, right? Avoid as many transparent objects as possible. So consider that I'm drawing an opaque object, right? So Unity will render that from the front to the back. Thus, anything that's covered up by the opaque item in the front or doesn't get drawn, right? Because it's front to back, and thus we avoid a lot of overdraw. However, transparent or translucent shaders and textures and materials draw from the back to the front, which means you're going to have a bit of overdraw that you could potentially avoid. So things like that. There are more, but that's just the sort of stuff off the top of my head. Unity's documentation on optimization, and specifically mobile optimization, is actually really good, so I highly encourage you to check that out. All right, so let's see here. If you see black textures, it probably means your texture memory is out. That's possible. There's a few different reasons we can see black textures. Normals aren't correct on a model or whatever, but yeah. Let's see here. Can you recommend a way to display ads in a mobile app developed with Unity? Yes, but not right now. That answer will make more sense in the future. Okay, let's see here. Let's see. Again, can you explain about 2D movement? But I really don't know what you mean. You'll have to be more specific. Let's see. Something about VSync. Sorry, I'm just trying to catch up. Do you know any good transparent cutout shader for mobile? Actually, the sample assets have a bunch of mobile shaders in them. So we can see, like we have mobile speculars. There's more. Wait a minute. Where are my shaders at? I gotta find them. So the sample assets actually have a bunch of stuff in there. I just don't know where. Nope, that's not. That's just mobile specular. They're in here somewhere. But basically, yeah. Sample shaders for mobile are available all over the place. You can write your own too. Just basically keep stuff really simple. I don't write shaders, right? So I'm not really good at that. So I can't really give you any specific information there. Let's see here. So you don't have to change anything on the camera for mobile games. Only the 6:10 aspect ratio on the game tab and your camera and assets will be correct on all devices. No. If I leave this at 16:10, this stuff will be correct for all 16:10 devices. So I need to test this, right? So this is me building my game for a Nexus 10, right? But let's say I also want to test my game for a Microsoft Surface tablet. So I will drop this down to, 16:9 isn't available. So I might create 16:9. Let's call this Surface. Oops, caps lock. Surface, fixed resolution, width is going to be 16, height is going to be 9. Okay, boom. So we'll put this in 16:9 aspect. Oh, did not like that. Whoops. That's strange. So it bugged out there. Normally you can just set this to 16:9. I don't know why that didn't work. But anyway, 3.4 isn't. Oh, it's because I'm in Android mode. That's right. And there are no Android things in 16:9 aspect ratio. So to test this in 16:9, I'd go build settings. I'd switch this over to Windows 8. I'm not going to do that right now because it takes a second to recompile everything. But I'd switch over to Windows 8, and then I would test it at 16:9. Then I'd switch over to iOS and test it at 3 or 4.3, and so on and so forth. So you got to test it at the different aspect ratios. But if it looks good on all the different aspect ratios, chances are you'll be pretty good. You might need to do some stuff to scale your textures appropriately. but you'll know that the camera will see what you need it to see. Let's see here. I think 2D movement is referring to movement on the 2-axis only, something about translate from keyboards to controls. Well, you saw that we already did that. When we used the accelerometer, we mapped it to 2 axes. We moved it to X and Z. If you want to simulate a 2D game, just map them to X and Y. But nothing else is really different there. Let's see here. 16 by 8. I don't know that there is any devices that are 16 by 8. Surface is 16 by 9. Oh yeah, so some people are here saying, but this build drop down list ratio doesn't affect the build ratio, or I'm sorry, resolution. It's only for the Unity view. That's correct. It allows us to test in all these different. I mean, the device is going to have whatever resolution the device has. There's not really anything we can do about that. But we want to test it to make sure it'll look good on all those different devices. There we go. How to optimize the screen resolution for different screen sizes, like Android. I have a lot of screen sizes. How do you handle it? I just told you, right? Basically, you build it and you test it against the different ones. So in this case, well, we're in landscape, so I'm not going to do portrait. So here's 3:2 landscape. Here's 16:10 landscape, and I can see that both looked all right. Here's a different type of landscape. So this just basically allows me to test it against all these different landscapes. So this one's a little bit crunched. So if I didn't like that, I might want to modify my camera a little bit or change my view size or whatever. But it basically, you kind of just need to put in the work, right? There's not like a simple magic button. And, you know, you got to kind of test it against the different aspect ratios to make sure it looks okay. But otherwise, you know, it's just something you got to do. All right, so at this point, we're going to kind of wrap up. I'm just going to look through any of the last questions here. And then we'll go ahead and wrap up. Let's see. What is the most optimum way to get an object from the scene? Is GameObject.find. Yeah, don't do GameObject.find. You'll see that I've done that in a few tutorials, but I've always warned you not to do that because it's not good. So no GameObject.find. You can do basically you can do public variables to click and drag. That works all right. Basically, you just need to get a reference to it somehow. If you're gonna do GameObject.find, only in start methods, but never during updates or anything like that, because that's a terrible way to do it. Let's see here. Any mobile games made with Unity that I would recommend? Oh, there's a ton of them, right? Years ago, they estimated that 54% of all mobile games were made with Unity. That number's gone up. So, you know, Temple Run 2, CSR Racing, Republic, yeah, there's a ton of them. So check our site. If you go to unity3d.com, you can see the games that we sort of showcase, and there's a bunch of them on there. Let's see here. Are there any screens or any scripts ways to define layout depending on screen size? Yeah, remember, you can always use screen.width and screen.height to determine what the screen size is, and then do whatever you want with that information, right? It's you know, it all depends entirely upon what it is that you want to do. All right, so okay, I'm gonna go ahead and end things here, but I think you all kind of got the point. So basically, mobile devices are basically just like really, really weak desktops, right? That's effectively what they are, and instead of a keyboard and mouse, you've got touch and accelerometer, right? Otherwise, you know, you kind of already know how to work with it. A lot of the stuff that you already do, you can do with mobile. There are some performance considerations, but for the most part, it's all fairly basic and fairly straightforward. I'll hang out here and chat a little bit just to kind of answer any more questions that you have, but we'll go ahead and end the video session here. Thanks again to everybody for participating. At this time, there are no new events on the Unity site. I've got to get them scheduled. I've just been sort of lazy. Next week's GDC, so I haven't done it yet. But we'll post the schedules for some more. So yeah, so I look forward to seeing you all next time. I'll get that all posted. And oh, real quick here again. Any questions, comments, concerns, follow us at Unity3D, at Mike Geig, which is me, at Will Goldston, and at the Ant Ranch. You can also email me, Mike at Unity3D.com. And yeah, thanks everybody for watching.